No, I didn't freeze it. It's just for you to check. I took my face away. I wasn't sure if it was blocking anything. I can put it back. I don't think it is. No? Yeah, I'm here. I'm looking over some of your work as you do this. But yeah, you should just be checking over your review. I'll leave it up there another minute so you can get through. If you don't finish checking through it, then again, this gets recorded. So you can just go back and pause the video on the answer sheet there. Fill things in. And if you have questions, you can ask. I can do a couple if you need it before we start our other things. What is 34? 34. Thirty-four is right here. It's C equals G over CT. Oh, sorry, S equals G over CT. Yeah, so how do I want to do this? And I want you to solve for S. So we don't know what S is, or we want to find out what S is. So what you're going to do is you're going to take this side and get rid of everything that's attached to S. So I'm going to divide by C and divide by T. So I'm going to do the same thing on this side, and you're going to get G divided by CT equals S. That will cancel, this will cancel, leaves you with S. That you can't solve. And the one that we're supposed to solve for the variable indicated in red. Okay, we can do a couple of those. Let's see. I don't have much room to write on here, but I just did 34 with you. Was it like 33? If I hide my face, I get more room, so I'm going to hide my face. I'm still here though. 33. 33 says, so if I'm doing 33, 33 says H equals 3W plus 2, and you want to solve for W. So I'll make W the red one. With that, you just manipulate it around. I'm going to I'm adding 2 over here, so I'm going to subtract 2. Subtract 2, this gives me H minus 2 equals 3W, and I'm going to divide by 3, and divide by 3, and this gives me, I guess there's different ways to write it if you're confused on how that's written, but this is H over 3 minus 2/3 equals W, or you could just have H minus 2 all divided by 3 equals W, or when you're dividing by a third, that's the same thing as multiplying, I'm sorry, when you're dividing by 3, it's the same thing as multiplying by a third, so you can have 1/3 H minus 2/3 equals W. So really, any one of these three would is technically a correct answer. Honestly, this is probably the one I like. This is the one your book liked, so that's what I put. But this is easy for me to work with compared to the other ones, really. So So you might have had just kind of a different notation for it, but all three of these mean the same thing. One isn't necessarily better than the other. It's just personal preference at that point, I guess. I just did 34, so I'll look at 35. 35 is probably the same kind of issue you had with 30, because you get that fraction going on there. So if I did 35, you have r equals 6n plus 4, and then the p is what's in red. That didn't work. Yeah. The p is what's in red. So again, same deal. I'm going to subtract 6n from this side because I'm adding it over here. So I'm going to get r minus 6n, and this will cancel. Will leaves me with 4p over here. And again, I want to get p by itself. I guess I should put that in red. I want to get p by itself. So then I'm going to divide by 4 and divide by 4. And again, this here is an acceptable answer if you want to leave it as r minus 6n over 4 equals p. Or again, you're dividing each term by 4, so you could break up your denominator into it and do r divided by 4 minus 6n divided by 4 equals p. And then once you get to that point, you can simplify your 6/4 if you wanted. Excuse me. And you can simplify your r/4 if you wanted, and that would be what is that? 1 over 1/4 r, because dividing by 4 is just multiplying by a fourth, minus, and then 6 divided by 4 you can simplify. Yeah, what is that? 3/2 n equals p. So really, again, any one of those is pretty good. 36 was the next one. I'll do 37 too when I'm done here. 36 is probably a little easier. Y equals, your x is on top here. Minus 4, and you want to get x by itself, so add 4 to both sides. You get y plus 4 equals x over 5, then multiply by 5. Just keep in mind you're multiplying this whole quantity by 5. So you're going to get 5y plus, and then do the 4 times y. I guess I'll write it like this first. 5 times y plus 4 equals x. Technically this is fine if you want to leave it like this. This is actually probably preferred. But your book takes it one more step further and asks you to distribute, to just simplify this side, which will give you 5y plus 20, because 5 times y is 5y, 5 times 4 is 20, equals x. So either one of these acceptable. I guess your book wanted you to take it out, but honestly this is probably a more useful answer to me, depending on what you want to do with it. I can see more uses for this than that, but whatever. I guess if you wanted to graph something, that would be easier. See, 37 I think is a word problem. Yeah, so this is simple interest. So remember, simple interest, you're using interest equals PRT. Just remember that formula. On your test, I will give that to you, so you don't have to memorize it, but it's a pretty easy one to memorize. Remember that I equals your interest. Remember that P equals your principal. R equals your rate, but it has to be in a decimal. And T equals time, but that has to be in years. So keep those things straight. Here it says you are depositing $800. I don't know how much room I have here. Can you still see? Yeah, you can still see. You're depositing $800, so your principal is going to be 800. So I'm just going to come over here and write P equals 800 at an interest rate of 1.5%. So your rate is 1.5%, but you can't use it as a percent. You got to change that to a decimal, so it's 0.015. And your T is 3 years, and that's already in years, so we're gonna leave it at that. So this is money. Sorry, this was years. This is already in years, so I don't have to do anything with it. Then I just plug into here. So I'm going to be doing interest equals 800 because P is 800, R is 0.015, and T is 3. And I just multiply that out, and I'll get my interest rate, which apparently should be equaling $36 in interest, but just to check it, 800 times 0.015 times 3 gives me 36. So your interest equals 36, and that's in dollars. Any other questions about that assignment? Is everyone checking it over? I'm not sure why they're missing something. I will give you another minute, then I'm going to move on to today's assignment. And again, if you follow along with me, you'll be fine. Yeah, Jack, you flipped a sign. Well, that was the question for 32. Why is it different or something like that? Whenever you find yourself multiplying or dividing by a negative, you flip the sign. I don't know if there's one in here. There should be one in here. Yeah, so 30, you end up flipping the sign. Did I copy that right? Yeah, 30 you should flip the sign. So you have 16 minus 4a greater than 8. Add 16 to both sides. 8 plus 16 gives you 24. Negative 4a greater than 24. In that case, here you're going to be dividing by negative 4. This right here flips the inequality. So that's going to flip it. This becomes a, and then 24 divided by 4 gives you your 6. Did I do that right? I'm sorry. Whoa. This is subtracting 16. Screwed that up. This is a positive 16, so I'm going to subtract 16 from both sides. This gives me negative 4a is greater than, then 8 minus 16 gives me negative 8. Then I can divide by my negative 4. Again, still dividing by my negative 4. So this is going to be my flip. It flips, this becomes a, because negative 4 divided by negative 4 is positive 1, so they cancel out. And then negative 8 divided by negative 4 is positive 2. So there, that makes more sense. But it's only when your divisor or your second factor is negative. So is when it's going to change. So think about any time that you're going to change the sign on one side of the equal side, it's going to flip that inequality symbol. Okay, let's start today's lesson. I'm actually just hiding this so it's still up there. Let's just hope I don't delete everything. But that's being hidden. So if you need to come back to it at the end, you can. But for today's lesson, we are going to be looking at page 398 to 399 in your book. And I highly suggest you have that open so you know what's going on. I'm going to start by just explaining what it's asking. If you can figure this out on your own, which really isn't too difficult, you just have to be able to read well, it's going to work out fine. But we're going to look at some modeling with graphing today. So that's what this is. This is going to be modeling with graphs. And this is very important in life because we like looking at graphs as opposed to actual numbers and stuff like that. But that's what it is. So it does give you an example first, and then it's going to ask you some questions, then it's going to give you example 2, and then it's going to ask you some questions. You're mostly going to be drawing today, so I am going to ask you to draw along with me. So get out a sheet of paper and do it. These are going to be rough sketches of graphs, so it doesn't have to be graph paper. It just doesn't have to be exact. We're just trying to look at a situation, then get an idea on what a graph of that situation should look like. So number 1 gives us this graph, or I'm sorry, example 1. So this is example 1. There's nothing for you to do here except for listen. You should see that it has parts of your graph. You have a y-axis and you have an x-axis. So here you should be familiar, this is your y-axis, and you should be familiar with the fact that this is your x-axis. It's been that way since the beginning. That hasn't changed. You have a dependent variable that goes on your y-axis, and for our purpose for the question, this is going to be distance from home. So this is measuring distance from home. And it's important to know what that's measuring. So it's important to read things that are coming out. And on your x-axis, this is going to be in time. And here we have 0. So this would be 0 time and 0 distance from home. And then it draws a graph, and your graph kind of looks like it goes up a bit, then it goes flat, then it has a steep incline, then it has a far flat, then it goes down a bit, then it has another flat, and then it comes back to the axis. And it's going to ask you to describe what's happening in this chart. And there are many different answers because there's not a lot of information here. But it does tell you that the graph at the right shows one trip from home to school and back. So you start at home, go to school, then you come back. The trip combines walking and getting a ride from a neighbor. Tell what the graph shows by labeling each part. So right away we labeled our axis, our y-axis and our x-axis. And we're going to show what's happening on each segment of the graph. And if you look at it closely, I'm going to pick a different color here. But you can see that between 0 and whatever time this is, you have like one segment. Between whatever time that is and this segment, you have your graph is doing something else. And then this here is an important point. Your graph is doing something else between these two segments. Your graph is doing something else between these two segments. Your graph is doing something between these two, and finally till the end. So you can see how I segmented off the graph, and that you should be able to do in your head. You don't have to sit here and actually do that, but I mean you should be able to see, hey, something is happening here, something's happening here, something's happening here, and something happens here, and so on. And they're all kind of different. They all look a little different from each other. So different things are happening as we go. And remember, this is us going to school and back. And we also get a ride at some point. So here we're going on our little trip. So first off, 0 time means we're just starting the beginning of our journey. And as I get further along this x-axis, I get further and further along my journey in time. I cannot have negative time. It's just not possible. So we don't have a quadrant 2 or a quadrant 3. You also can't have negative distance. Again, just not possible. You can't travel in a negative distance. So you don't have quadrants 3 or 4. So in this case, we're only concerned about quadrant 1 because of those facts. And those are important to realize. There are some variables that you can have negative of. For example, temperature. If time went on and we had temperature here, we could have negative temperatures. So you would have something down here in this area. If this wasn't time, if this was something else, you might have a negative version of it. In that case, you'd have something over here as well. So it is important to pay attention to what you're measuring and how those measurements actually act in the real world. So here, I'm just going to label my segments here. So I'm going to call this segment 1. I'm going to call this segment 2. I'm going to call this segment 3. This is segment 4. This is segment 5. This is segment 6. And this is segment 7. And I'm doing that just so I can see what's going on. If you look in your book, it just has arrows pointing to them. It's just going to get cluttered when I explain it. So from segment 1 to 2, or in segment 1, from start to whenever segment 1 ends, right? This here is you walking away from home. So here I'm going to say walking away from home. And that makes sense. You can see our distance from our house, our starting point, is increasing, right? Distance started at 0 and is now over at whatever this distance is. So our distance is going up. Number 2, you should see that as time goes on, distance is staying still. So this here is you actually stopped. Stop / not moving. There is no motion going on there. Maybe this is you actually getting in your car. I don't know what your book says. Yeah, your book says this is you getting in the car, but you're not moving at this point. Your distance from your house is not changing, so there is no motion, and therefore you have a flat line. Section 3 is your car ride to school. And you can see how this line here is longer, and in your book it's easier to see that it's steeper. Mine is not the greatest in steepness. I tried, but you should see that it's steeper, meaning that you're going faster too. So you're covering more distance in less amount of time. Section 4 here is you're at school, right? Your distance from home isn't changing when you're in the building. And then you're going to go in reverse. You're going to have your car ride home, and then you're going to be getting out of your car. At section 6 is getting out. And at section 7, you're walking home again. So you can see how we can read this graph based on the different things. And that's kind of like your example there. So let's walk through number 1, what you need to do for number 1. So here I am going to try to delete. So again, if you look at the assignment, you can't turn in number 1 because it's a drawing, so don't turn it in. But I do want you to still do it. Number 1 says to describe this graph here. So looking at it and give a scenario for this graph here, and it gives you It gives you time over here, and it gives you distance over here. Actually, this is distance traveled, which is a little different than distance. So that's the total distance traveled. So this is the graph that it gives you, and it wants you to explain segments of it. So again, just looking at it here in this segment, I'll change the color again. Right here, I got a segment. There, I got a segment. There's a segment, and there's a segment. So I got 1, 2, 3, 4 different segments there. What's happening in section 1? Go ahead and describe what's going on here. Maybe you're walking. Right, section 2, there is no movement, it is a flat line, so you are stopped. Section 3, you should note that your distance is changing faster compared to section 1, so maybe here you're running. So you are moving faster. And number 4 is, again, it's stopped because there's no slope. When it comes to distance versus time graphs, slope of your line is the steepness, and that represents speed. If I can spell speed right. Right, because you know speed equals distance over time. So distance divided by time is slope, because slope is also rise over run. I'm not sure we did a lot of slope this year, but rise over run. So your slope here is equal to speed. So here the slope, the steepness of this line is greater, so you're going faster. The steepness of this line is less, so you're going slower. So have something that says, hey, you're going faster or slower. Would a line going straight up or down be teleportation? Actually, Luke, it is impossible for this to happen. Even if you are teleporting. If you had a line going straight up and down, like this, right? It's not possible because that says you are at this position and this position at the same time. So this is actually saying that you're in 2 places at once. And that's not possible unless you play with the words and be like, hey, I'm standing in the threshold of a door, I'm in the room and out of the room at the same time, right? But it's actually not possible to have vertical lines. And that's going to come in the fact when we talk about functions. For functions, right, things like f of x equals mx plus b is a line. I don't know if I've showed you that before or not. When it comes into functions, you can't have 2 y variables for 1 x variable. It just doesn't work. Right? So if I plugged in numbers or something, you're only going to get one possible thing. And that, again, that's because you can't be in 2 places at the exact same time. Teleportation, which is still going to take time, might look like a piecewise function, which is possible. So if we have our line going, you're walking, you stopped, then you teleported up here. We'll actually have to have a circle here and a dot here because I can't include this value, but I have to include this value. And go like that. That would be teleporting. But you can't be in 2 places at once. So, and I think number 3 has a piecewise function that's like that. But let's look at number 2. Just walk you through number 2 again. There it goes. I'm going to look at number 2. I guess I'll just continue doing in blue. Number 2, we have weight of a dog. In time. And this one here is a smooth curve, which is interesting. and it looks kind of like that. And again, you're going to look at this and you're going to just kind of guess on where, I'll go with black this time, where it's going to change. Like, hey, this is doing something here, it's doing something here, and it's doing something here. They're all a little different. So let's describe these three regions on what's going on. So in region 1, clearly it's weight of a dog. This is time. So this is like when it was first born. So this is dog as a puppy. This is your puppy phase. In your puppy phase, you should note that it doesn't grow as fast as when it is your kind of your child phase. Like even with you, this would be your growth spurt in number 2. So this is dog as a puppy. Number 2 would be your growth spurt. However you spell spurt. That's your growth spurt. And then number 3 is the dog's just kind of like being a dog, like an adult dog, I guess. Right? And so there is a time period where your dog like grows, well, exponentially is what it's actually doing here, compared to more of a linear thing, which is what it's going to happen there. And that's true with you too. You start off young and you stay small for a while, then you hit your growth spurt and you shoot up in size, and then you kind of level off towards the end. And even some might even kind of go down towards the end. You might actually shrink or get smaller as you get older. But that would be number 2. Number 3 you actually owe me work for, so definitely pay attention to this one. Number 3 is the graph at the right is a step graph. It shows prices at a parking garage. So let's look at the piecewise graph. I don't know why they call it a step. Well, I guess it looks like a step graph. This is a piecewise graph in my eyes. It's a piecewise function, meaning it has a bunch of pieces to it. Over here we have cost in money, and over here we have time in hours. And I don't know how often you go to parking garages or things like that, but they have rates, and you can see it has like a 2, 4, 6, 8, and 10. My graph is going to be smaller. And we have 2 hours, 4 hours, 6 hours, and 8 hours. And you can see if you're going to park for 2 hours, anywhere between 0, which you don't pay anything for, so it is an open circle, to 2 hours, and that includes the 2-hour mark, costs $2. If you're going to park longer than 2 hours, it jumps to the next pay level, which would be anything, which would be $4 in this case. So between 2 and 4 hours, it costs $4. And then for 6, again, 4 hours is still in this $4 bracket, so it's not going to be in the $6 bracket, but 6 will be. And then for 8, goes like that. And then for 10 and up, I guess it doesn't show 10 and up, but assuming because that stops, it might just be like that forever. But this goes with price. So for anywhere between 0 and 2 hours, actually anywhere between, well, 0 is not going to work, but I mean it's, see, this is why I like calculus notations. If you like your inequality, anywhere between 2 hours and 0, but it doesn't include 0, it's going to cost $2. Right? Anywhere between 2, like greater than 2, but less than 4, it's going to cost $4. And you'll note that it will never cost you $3 to park here. It just, there's no way this line here is going to cross the 3 mark here. It's just not part of the pay scale for it. Actually, I guess this is wrong. that would be 2, that would be 4, and so on. I mean, you can look at the graph on your paper, and in that case, this would be 1. Sorry about that. This would be 1. That would be 2. I got my scale messed up. I didn't copy that too well. And then it'll go up however you do it. So that would be 1 hour, 2 hours, 3 hours. So between 2 and 3 hours, it costs $6. Between 3 and 4 hours, it costs 8. You can look at the graph on your book, though. It's a little better. So for 3A, it asks, how much does it park for less than an hour? So looking at your graph, if you're going to park in this section here, how much does it cost? And that's $2. Right? So you should be, on your answer sheet, you can put $2 down. For 3B, looking at this, how much does parking cost for 4 hours and 20 minutes? So that's above 4 hours, but less than 5 hours. So looking at it, 4 hours is coming up to be, oh, I screwed up the y-axis too. Don't look at my graph. Look at the graph in your book. I didn't copy that well. But looking at the graph in your book, 3B, if you need to do anything else if you finish the work. If you understood everything through 5 through 9, then yeah, that's what we're doing today. In fact, I'm probably going to end this soon because it's getting to the point. But if you can do 5 through 9, I'd like to go over it probably next after your test. But this class is getting long, and I do have a meeting today I got to get to. But you can just look at the graph and read it. Try your best on it. Yeah, actually looking at the time, we got to end this now. So go through it. Just try to sketch graphs for 5 through 9 if you can. Like I can do 5 real quick. Right, temperature throughout the day. You're going to start at, this is time, this is temperature. You're going to start low and get high. And it's going to pan off at the end there. Something like that. Right, your high temperatures will be in the middle of the day. Low temperatures will be on the end. So this is asking you to do that. Just kind of get used to reading graphs. We're actually going to, well, I don't know if we are, but you're going to do a lot more of that in physics next year too. So with that, email if you have questions. Test tomorrow. So if you don't understand something on the review, email it. You have a copy of the answers. Double check things. I do not plan on streaming tomorrow because you have a test. And then on Monday, we will finish this assignment and go over all the answers to this one and maybe move on. So with that, I am going to end it because I got a meeting I need to get to. So I will talk with you Monday if you don't email. So thanks.